Hi everybody, it's Mrs. Martello. Today we are going to talk about what's called rationalizing the denominator. So when a fraction has a radical in the denominator, the fraction is not rational. Now we just learned about what a rational number is and what an irrational number is, so we should be familiar with this term. If the fraction is not rational, we must rationalize the denominator. Let's go through the steps of how we're going to rationalize the denominator. Our first step is we're going to take the radical that's in the denominator. Whatever that radical is, we're going to take that radical expression. We're going to multiply the numerator and the denominator by that radical. When you multiply the numerator and the denominator, that makes a fraction that's really equal to 1. So essentially we're just multiplying it by 1, but we're going to end up canceling out the radical in the denominator, which is what we want. So then we're going to multiply across the top and across the bottom, and then we'll simplify. Let's look at some examples. So our first example is 1 over the square root of 5. Now this is not a rational fraction because it has this square root of 5 in the denominator. Therefore, I'm going to rationalize the denominator. I'm going to take this radical that's in the denominator and I'm going to multiply radical 5 by the numerator and by the denominator. Now this fraction, radical 5 over radical 5, essentially equals 1. So I'm really just multiplying this original fraction by 1, not changing the value of it, but look at what happens when I multiply. So let's multiply across the top. 1 times radical 5 is radical 5. And then on the bottom, radical 5 times radical 5, we're going to multiply under with under, and I get radical 25. Now, this radical 25, or the square root of 25, is a perfect square, so let's go ahead and take the square root of 25. The numerator stays the same. I can't simplify the square root of 5, but the denominator becomes 5. And this is our final answer. We cannot simplify this anymore because this 5 is underneath a radical and this 5 is not underneath a radical. So these cannot be simplified. Let's look at our next example, number 2. We have the square root of 10 divided by the square root of 3. Now, this fraction is not rational because of this radical in the denominator. So we're going to rationalize the denominator. Let's take this radical, radical 3, from the denominator, and we're going to multiply the numerator and the denominator by radical 3. Again, radical 3 over radical 3 essentially equals 1, so I'm not changing the value, but I am going to fix this radical in the denominator. Let's multiply. Across the top, radical 10 times radical 3, we're multiplying, becomes radical 30. And then in the denominator, radical 3 times radical 3 becomes radical 9. The numerator I cannot simplify. 30 is not a perfect square, nor does it have any perfect square factors. So the numerator is going to stay the square root of 30. But our denominator is a perfect square, so let's take the square root of it. It becomes 3. Again, this is our final answer. It cannot be simplified anymore because the numerator is underneath a radical and the denominator is not, so they cannot be simplified. Okay, let's keep going. Let's look at some more examples. Number 3, we have 7 divided by the square root of 2x. So again, this is not a rational fraction because of this radical in the denominator. Let's rationalize the denominator. We're going to take this whole radical in the denominator and we're going to multiply the numerator and the denominator by radical 2x. Okay, we're going to multiply. When I multiply across the top, remember this 7 is outside of the radical and this 2x is under. I can't multiply them together. Remember, I'm really multiplying outside with outside. So 7 times 1 is 7 and radical 2x stays the same. In the denominator, let's simplify. Radical 2x times radical 2x, multiply under with under, becomes radical 4x squared. Now I can simplify this more. In the denominator, both 4 and x squared are perfect squares, so let's take the square root of both of them. The top stays the same, 7 radical 2x, and the denominator, take the square root of each, becomes 2x. And that becomes our answer to this question. So if you're noticing what's happening, what happens when you multiply the radical by itself, it ends up being that number that's under the radical symbol. So let's look at what happened in number 1. When I multiplied radical 5 by radical 5, it became radical 25, which really equals 5. So radical 5 became 5. Look at number 2. Radical 3 times radical 3 equals 3. Look at number 3. Radical 2x times radical 2x equals 2x. And that's going to keep happening, and that's why we're multiplying the radical by itself so that we can cancel out the radical. Okay, let's look at some more. We're going to look at number 4. Radical 5 divided by radical 3n. This is not rationalized, so let's rationalize the denominator. We're going to take the radical, let's multiply the numerator and the denominator by radical 3n. Okay, we're going to multiply across the top. This is under the radical and under the radical, so I can multiply them. This becomes radical 15n. And in the denominator, let's multiply under with under. This becomes radical 9n squared. Let's simplify. The numerator stays the same. I cannot simplify radical 15n. And in the denominator, 9 and n squared are both perfect squares. Let's take the square root of each one. It becomes 3n. And you can notice again, look at what happened to the denominator. It was radical 3n times radical 3n, and it became 3n. And there's our final answer. It cannot be simplified anymore. We're going to look at one more. Let's look at number 5. So number 5 has a couple things going on here. First, I noticed that 4 and 6, they can be reduced. I can reduce them now or I can reduce them later. It doesn't matter when you reduce them. I also noticed that y squared is a perfect square and can be taken out of the radical. So the first thing that I'm going to do is I'm going to reduce the 4 and the 6 to make it radical 2y squared over 3. So I just reduce them both by 2. Next, what I'm going to do is I'm going to split this up so that the numerator and the denominator each have their own radical. I'm going to give 2y squared its own radical, and I'm going to give 3 its own radical. This is the quotient property of square roots, which allows us to take the fraction and give each numerator and denominator their own square root. The next thing I'm going to do is I'm going to take this y squared, which is a perfect square, I'm going to take it out of the radical. So I'm going to split this up and make this radical 2 times radical y squared over radical 3. Okay, again, this y squared is a perfect square, so let's take the square root of it and I'm going to put it in front of this radical 2. So this becomes y times the square root of 2 over the square root of 3. Okay, we're almost done. However, the denominator is not rationalized. So now we're going to do what we did in the top portion of these examples. Let's take this denominator and we're going to multiply the numerator and the denominator by radical 3. Let's multiply across the top and across the bottom. Remember, there's really a 1 in front of here. So outside gets multiplied with outside. Y times 1 is y. Under gets multiplied with under. 2 times 3 makes 6. So y radical 6 on the top. And then in the bottom, radical 3 times radical 3 is radical 9. Last step, 9 is a perfect square, so let's take the square root. We're going to keep y radical 6 on the top. The square root of 9 is 3. And that's our final answer here. You could have done this problem in a different order, but you eventually have to do all of these steps. But if you did the steps in a different order, you would end up with the same answer.